Hey, what's going on, guys? Let's do this problem right here. The question is asking evaluate the following telescoping series. So we have this function right here. Let's see how we can do the telescoping series. So the first thing is we are going to do the partial fraction decomposition. So to do that one, what I take this part only. So 1 over, instead of writing n square plus n, I can separate this one as n times n plus 1, right? Same thing. And if I do the partial fraction, this is going to be a over n plus b over n plus 1, right? Now to get rid of this denominator, I multiply both sides by this denominator. So this is going to be n times n plus 1 both sides, right? So n times n plus 1. So if I multiply this here, this is going to cancel altogether, and that's going to give us just 1. And here if you see n cancels, we are left with n plus 1. So this is going to be a times n plus 1. And then we have plus b times n plus 1 cancels, we left with n. So this is going to be bn, right? Now we have to find a and b values. So that's the main thing for doing this one. So here to get the a, we had to get rid of this b. So which n value we had to choose in order to get rid of this b? If you think about this, if I plug 0 for this n value, b will become 0, because b times 0, that's going to be 0. So let's choose n is equal to 0. So here if I choose n is equal to 0, b will become 0, then this is also going to be 0, so a is equal to 1. So from this one we can directly find out a. And to find out b, we have to get rid of this a. So which value should I plug for n to get rid of this a? So if you think about this, -1. If you put -1, this is going to become 0, and that will make a 0. Then we can find b. So this is going to this will become 0 if I put -1. So n is equal to -1, and we will have negative b is equal to 1. Therefore b is equal to -1. Now we can go ahead and write this one in terms of these values. So this is going to be 1 over n, and then other one is going to be -1 over n plus 1, right? Now what are we going to do is I bring this one back. So this is going to be sigma n equal to 1 to infinity 1 over n minus 1 over n plus. So to evaluate this one, what we had to do, we had to do the partial sum to see the pattern, like to see the relationship, right? So if we see the relationship, we can form a new equation. So that's the main thing. So here what we can do is, let's plug 4 values just randomly, right? You can pick 4, 3, you will get the same pattern. So let's take 4 values and see the pattern first. So if I plug 1 for this n value, that's going to be just 1. So this here we are going to have just 1 minus 1 over 2, right? Minus 1 over 2. Then if I plug 2, this is going to be 1 over 2 minus 1 over 3. And if I plug 3 for this one, that's going to be plus 1 over 3 minus 1 over 4. And if I plug 4, this is going to be 1 over 4 minus 1 over 5, right? So when we go for sigma n is equal to 1 to 4, this is what we get, right? So from this one, let's see the pattern. Let's cancel everything we can cancel. And if you see that negative half and positive half cancels, so these two cancels, and negative 1 over 3, positive 1 over 3 cancels, and negative 1 over 4, positive 1 over 4 cancels, and we are left with negative 1 over 5, right? So the pattern seems like if it's 1 to 4, the pattern is 1 minus 1 over 5. What happens if you go for 5? You will get 1 over 5 minus 1 over 6, negative 1 over 5 cancels, and 1 over 6 left. So it seems like whatever the value choosing we are, like if it's until 4, it's going to be 4 plus 1. If it's until 5, it's going to be 5 plus 1. So if it's k, if it's n is going to 1 from 1 to k, this value is going to be 1 minus 1 over k plus 1. So that's going to be the pattern, right? Now we have to find out which value it converges to. To find that one, we take the limit. So if I take limit for this function, this is going to be limit n approaches infinity, and if I put this value for here, right here, it's going to be 1 minus 1 over k plus 1, and if you plug infinity for k value, this is going to be 0, because 1 divided by infinity, that's going to be 0. So we left with 1 minus 0, that's going to give us just 1. So the final answer is this function converges to, this telescoping series converges to 1. That's it. And that's how we do these kind of problems. I hope you guys find this video helpful. See you next time.